Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. For today's episode, I'm joined by Richard Savoie, who is the co-founder and CEO of a really interesting tech company called Adiona Tech, based out of Australia. So it's his evening and my morning, and we're trying to make this work. But welcome to the show, Richard.
Thanks for having me, Ryan. Really pleased to be here.
So if we could just start out by learning a little bit more about you, please. Tell us about your background and where you're from.
Thanks. Happy to. As you might have noticed from my accent, I'm not originally from Australia, despite having been here for 15 years now. I grew up in Boston and studied electrical engineering and went on to design medical devices for about 15 years. So cardiology and cardiovascular equipment. And was managing a company here in Sydney after my wife lured me here, trapped me here. And not that I'm bitter or anything. It's a wonderful place to live. You've been here quite a bit, so you know exactly how great it is. But fully embedded in Australia, was working in cardiology. And when I left that company, I wanted to start my own venture, and I wanted it to be sustainability positive and socially positive. And ended up landing in the logistics and mobility optimization space, a bit by design, a bit by accident, as things often happen. And now we've been running for about 5 years now as Adiona Tech, and helping large organizations like Australia Post and Coca-Cola and PepsiCo and Amazon DSPs to become more efficient and reduce their emissions.
Yeah, cool. So just then going back a bit, you got in, you studied electrical engineering or electronic engineering. What
electrical, but with a computer focus. So not, power transmission and things like that, as is often the domain of electrical engineers. It was our degree at Northeastern University in Boston was called ECE, so electrical and computer engineering.
Okay. And what was the attraction to that in the first place? You know, when the young you was kind of looking out at the future. I often sort of think I think we're a similar age, so if you won't mind me saying, but back then, so what seems like an obvious career choice now wasn't necessarily 20 or so years ago.
Correct.
What was the attraction?
That's a great pickup. But at the time, it wasn't on my radar at all. It was definitely not on my radar at all. I wanted to be a doctor. I wanted to be a pediatrician specifically.
Okay.
That's a long story. I mean, the short version of it is that I had really severe asthma as a child, and I was in hospital because of asthma. And I always really just looked up to and appreciated the medical professionals, doctors and nurses that were always looking after me. And I thought, wow, what a great thing to be able to do in your life is to help some sick kids. It just seemed, even when I was really young, like a really noble thing to do.
Yeah.
So that's what I wanted to do when I was young. And, baseball playing and being an astronaut wasn't exactly working out either. So, but by the time I got to high school in year 11, so junior year in American parlance, I took physics. And we had a unit in physics on electricity.
Right.
And I just fell absolutely in love with it. I was intrigued with physics generally. I thought that was just a really cool domain that I'd never really experienced. But specifically understanding how electricity worked just pulled back a piece of the matrix that I could not unsee.
Yeah.
And really got fascinated by it.
Okay, cool. That's, you often see, unfortunately, even still today, engineering disciplines fail to attract, enough people, but medicine's highly competitive, and it's a lot of people seeing what's in front of them. Experiences like yourselves, and maybe not that many people deliberately taking electronics equipment apart or sort of appreciating the engineering that goes behind the day-to-day items. Much more so now than it was back when we were kids. So no, that's a really good entry into it. And then the medical devices engineering that you were involved in for such a long time is a pretty natural segue of those two interests.
Exactly. It was really an amazing convergence of those two interests, or multiple interests too, because kind of to your point too, I was always a tinkerer. I was always into puzzles, and I was taking things apart and fixing things. And my dad was a master electrician, so I think there was also some crossover there in terms of understanding how electricity works and stuff. But understanding how to wire a house and install a ceiling fan was just very pragmatic for me, and it was a great set of skills to have. But it wasn't something I wanted to do for a career.
Yeah.
Then being able to combine all those things and then add that layer of medicine and helping people through healthcare systems and all that added a layer of romance to engineering that I found really, really intoxicating.
Fantastic. And in that sort of time period, the jump to Australia happened. Was that led by work, or was that you mentioned your wife? Was it led by your good lady?
Yeah, it was. As is often the case, especially when you talk to people down here, like expats in Australia. It's often a partner that lures them down. But unlike the typical scenario, my wife is actually from Boston as well.
Okay.
Like we knew each other in high school. We grew up together, and we didn't get together as a couple until later on in life. And she had just basically accepted an offer to come and work in Australia, and said, "Hey, do you want to come down for a year? I've just got this 1 year contract. We'll go on an adventure and check out Australia and see what it's like." And that 1 year turned into 2, and now 15.
Right. Wow. And so we've mentioned Australia, but then specifically, which part of the country are you in?
In Sydney.
Sydney.
Southeast coast. Yeah.
Okay. And is there much of a sort of technology cluster around Sydney?
Well, it's interesting. When I did decide to move here, I had a great job with Medtronic, which is the biggest medical device company in the world. I was technically at Covidian, which was just kind of going through the process of being acquired by them. Loved my work, loved what I was doing, and very much research and development, engineering, design, and really loved it. And it was a big concession to move to Australia because there is not a lot of medical device research and development here. There's a lot of sales and marketing for those types of companies, but most of the, shall we say, engineering and innovation work here is mining related or mining adjacent.
Right.
At the time, maybe 15 years ago, there was also still some automotive stuff going on here, but it wasn't really R&D. Most of the R&D really was not technology; it was mining. Australia just is known for digging stuff up out of the ground and sending around the world, which is great. But it meant that I didn't have many options when it came to staying in medical devices. But I was very lucky, and I found a small cardiology company here that was founded by a cardiologist, kind of a self-taught engineer. And he wasn't even really hiring, but we got connected through a recruiter that said, "Hey, just, meet for a coffee for some networking and see if he can help you navigate and find some opportunities." But by the end of the coffee, we were saying, "Hey, it might be actually pretty cool to work together." And so I ended up going to work for him for 7 years.
Wow. Oh, fantastic. And did you manage to launch products and things during that time?
That was one of the most exciting parts of my career because the company itself was about 20 people in Australia and maybe another 5 people at a satellite office in the US. And they were really focused on a very specific domain and a very specific set of cardiology products. That's the story for another time. But I had a lot of autonomy in there. So by the 3rd year, I was basically running the day to day and also launching all of these new product lines and launching some other spin out businesses that weren't even related to the core cardiology business. It was just that I had a lot of freedom to explore and to look at new business opportunities, even in different domains. And so that gave me, I guess, my first official taste of entrepreneurship beyond selling candy to kids in high school and having a paper route and all those types of things. I dabbled with entrepreneurship when I was younger, but always really low risk stuff. I think, working in this company gave me the understanding of how to actually manage a small to medium sized business from end to end. I got all these skills that I never would have had working in a big company. And also that thrill and that dopamine hit of seeing an idea take flight and come to fruition and being able to go and bring it to market. And that was really exciting to me.
Yeah, fantastic. So that's where the entrepreneurial piece came in. Do you, you then, it's quite a big jump from sort of medical tech and that sort of hardware I'm presuming hardware domain, and unless there was software involved in that, into more of a software domain and the logistics sector. What inspired that move?
Well, okay, it was hardware and software. So the nature of the devices we were making, there was firmware, there was application software at the user level. So I knew enough to be dangerous with software, and I'd always done projects in software from my early days in engineering, but I was not a developer myself. But
Yeah.
I knew enough to be dangerous to manage them. Right, I could manage teams of developers, and that I felt really comfortable. And also, I think medical devices uh, it's such a high quality and regulated industry that
Yeah.
the quality management systems, just like automotive and things like that, you really do get a discipline that you don't get in a lot of other industries, which when you bring it to software can be very valuable. So I had all these skills, I had all this training and all this domain knowledge, but I had no business running anything in logistics. But I had an idea. The idea was actually based around my sister's life back in Boston. She'd always
Okay.
worked in retail, and she was at the time working at a grocery chain. And she would go past three instances of the exact same grocery chain to get to the one that she worked at. So imagine, going past in the UK, three Tesco's to go and work at a fourth Tesco.
Yeah.
Why can't you work at one that's closer, right?
Yeah.
Now imagine that problem at scale. And what we did is, I went out and I actually collected data from a bunch of grocery stores here in Australia. I wanted to be able to prove the concept. And I looked for someone who was experienced in that domain, that algorithmic optimization domain, which was so foreign to me. I knew nothing about it, but I just knew, oh, this could be a problem that's solvable. I don't know. And I met my co-founder, who's still my co-founder and, my right hand to this day. At the time, he was a PhD student and in complex optimization in computer science and machine learning. And I said, oh, this is the problem I'm trying to explore. I want to see if there's a solution. I want to see if there's a benefit to redeploying people to have a shorter commute and shorter travel.
Right.
And the coolest thing, and probably the thing that made me gravitate towards him so quickly is immediately he said, oh yeah, I could write an algorithm to do what you want to do, and we could test it. And he was so confident that, oh, I understand the problem. I understand what we would need to do to write an algorithm to test it. And I said, really? Is this a domain that people work in and understand? And he said, yeah, operations research, we do this kind of thing all the time. I'm like, wow, that's amazing. Long story short, the application that we built to do that was very effective. So even in the first data set that we did with the grocery employee data that I collected, you could redeploy people to the optimal locations to minimize the commute time of the group, and it would reduce the aggregate commute time by 31%.
Right.
Without increasing anybody's individual commute time. What's the benefit for a business? Well, the benefit for a business is it's very well proven that when people have a shorter commute, they stay in a job longer.
Yeah.
And in businesses like that, the turnover is around 20% per year. So if you can reduce the amount of turnover of jobs that people have, you reduce your recruitment, training, onboarding costs, all the other overheads that go along with that. But we couldn't get the business to work. We couldn't get the right level of investment to build out the integrations that you would need into the human resources software ecosystem. It was too fiddly. It was too foreign. People didn't understand why we even bothered.
Yeah.
I think, at a corporate level, people are like, why do you care about the commute of somebody that works in a grocery store? And I go, this is a personal mission to me. And I also see the flow-on effects of reducing congestion in cities, reducing emissions from vehicles.
Yeah.
At the time, electrification was very nascent. This is 2016, 2017. So anyway, it wasn't working, and it was kind of tanking, and I was having trouble continuing that business. But we got very lucky because along that journey, we got introduced to Coca-Cola. And Coca-Cola said, yeah, no, we can't really use what you're doing, but you have come at it from a very clever angle that we haven't seen before. Could you look at some of our fleets? And we thought, yeah, that's actually pretty relevant to our North Star of doing something that improves sustainability and improves efficiency and reduces congestion in cities and these things. We'll look at the fleets. So we ended up building a very custom route optimization engine for them, an application for them. It was very successful. And that basically kicked us off in the direction that we're on now, which is, optimizing fleets and logistics and delivery, and also converting them to EVs and building a platform for the future of autonomous delivery fleets.
Oh, okay, cool. So that's it's a very, very sort of decent business, lots of logistics operations and things to land. It was a sort of Halo customer. Um, where have you gone since then, and what's the business model? Do you build these things for people on an enterprise basis, or it doesn't kind of feel like the sort of thing I could just log into a website and tap in a few details and I've got an app to do it or something. It sounds a bit more involved than that.
Well, that's actually one of our strengths and one of our keys to success is that we do target big enterprise, medium and large enterprise are our core customers. But we've built it in a way that it's very simple to use for both the end users, people who do warehouse dispatch and route planning and things like that, drivers who use the mobile apps in the field, and even the developers who take our APIs and integrate them into enterprise systems, into big end of town like SAP and Oracle and Microsoft and things like that. So that's definitely been a key to our success is simplicity and usability. But it is designed for enterprise. So our clients tend to have fleets of 20 or more vehicles, trucks, vans, cargo bikes, whatever it happens to be. They do distribution, either last mile distribution or line haul distribution. But it also works for brands that don't have their own fleets and manage all of their deliveries and movements externally because it builds a digital twin of their delivery network that any third-party logistics company could operate within. And it gives them all this power to then simulate changes. So for instance, a big part of what we do is we built our own EV routing engine.
Right.
And in our environment, in this digital twin, people can do scenario analyses where, we have a library of 150 different EVs and they can say, well, here's our fleet today. We're running a bunch of 2-ton diesel vans. Well, which of these routes would be available to electrify as low-hanging fruit? Which ones have a range profile and a payload profile for the vehicles, and which vans would then be suitable? And then we can go look at total cost of ownership and grid requirements and charging cycles and things like that. But, at the end of the day, all of these fleets that we work with, and pretty much I would take a safe guess that every fleet in the world still have to prioritize on-time, in-full delivery for their customers before they can even consider anything like electrification or autonomy or changing things. You have to look after your customers and serve your business. But then once you have that modeled and you have this digital twin environment to simulate it, you can start to explore the edge cases and explore the long-term transitions.
An interesting sort of digital twin aspect. I mean, one thing that does strike me constantly with the logistics industry, obviously, you're in on time in full is clear, but the other thing, it's highly competitive. So getting cost out of a business like that, but a cost that whether actually the business is very dynamic, and you got things that happen constantly that are outside of your control, in terms of what's happening with the road system and your vehicles to a certain extent, maintenance size of things and maintaining uptime and things like that. So does your technology take the sort of external factors into account when those models are built and allow optimization around that?
Yeah, to some extent. I mean, it's not a fleet management solution in the sense that, they don't use it to plan their maintenance activities or downtime vehicles or things like that. It's very narrowly focused on solving the efficiency problems and optimization. And the main reason, and I think this would be relevant to your listenership, is transportation is the second largest greenhouse gas emitter globally.
Yeah.
So it's on track to be the number one for a couple of different reasons. A, because grids are electrifying, or not grids are decarbonizing at a pretty fast rate globally.
Yeah.
So that's coming down. While meanwhile, e-commerce and delivery activity is going up, especially in emerging economies in Southeast Asia and things like that. So you got this massive inversion where transportation is becoming a bigger share and an increasing absolute value of emissions globally.
Yeah.
And then you look at the efficiency of these fleets. And in the UK, very similar to the US and Australia, delivery vehicles run on average 40% empty.
Yeah.
There's a massive amount of empty running, especially when they go and they deliver a full van or truckload of payload and then they come back empty. If you average all that out, there's a massive efficiency problem. And, that's in commercial delivery fleets, commercial logistics. In personal passenger vehicle logistics and passenger EVs, it's a bit more straightforward because you're swapping one for one. You're taking a petrol vehicle and you're swapping it for an electric vehicle, and you're going to reduce your emissions that way.
Yeah.
But in commercial logistics, it's not so simple. You can't just do that because the cost is very different. The range is very different, especially underweight and at temperature. And I think, as you said, it's a very competitive market, and they've run on low margins. They have very capital intensive businesses on low margins. So they will sweat a vehicle until it's in the ground. They will dig a grave for these diesel trucks before they let them go, because they just don't have money to go and invest in buying new vehicles all the time. So we're helping them solve all these things by giving them a platform that helps optimize their day-to-day today, reduce costs, reduce emissions, better repeatability and clarity for their drivers and their workforce, which is awesome for everybody. And then at the same time, giving them this platform to then experiment, well, what's next in a 1 year, 2 year, 5 year, 10-year horizon.
Interesting thing about what you're doing, and I wonder how you think about this, but so a lot of time we talk about digital twins and sort of software simulation and optimization. We're thinking about something physical, like I don't know, think about aerodynamics and computational fluid dynamics, and there's optimize the process, and that obviously that industry is pretty much shifted from physical testing into digital testing, and then with an element of physical testing afterwards. But it's been an evolution where the whole industry was used to physical testing, so people spending time in labs and wind tunnels and so on, and then these software tools were introduced to aid that process and sort of reduce the testing time, and then it's moved on from there. The industry that you're in, it's not really been in the habit of, they don't run a test route and see. So in their kind of prior to having this kind of technology available, what did they do for optimization? And is it a completely new sort of thing that you're having to sort of educate the market on? Actually, have you thought about doing a digital twin and doing this testing and analysis and running different simulations? Or was there some kind of parallel to the wind tunnel in that space where they were actually testing stuff out before they were putting routes down?
That's a great question, Ryan. I mean, this is a pretty old school industry that has been slower to digitize than a lot of other industries. So I do remember seeing my first CFD package when I was an engineer, and seeing how they were modeling laminar flow inside of lumens, for fluid flow. And I was just like blown away that you can do that in software, and it would be anywhere close to the real physics. And that's definitely influenced me in this journey too. But keep in mind, really the biggest unlock, we've had a couple of different unlocks in this industry that have driven this ability to simulate. The first one was availability of GPS. So in the early 2000s, when GPS became more pervasive, suddenly they had access to see where vehicles were going all the time and guide them and all that. But it was still generally done via, pins on a map. Oftentimes I joke that it looks like some cops hunting a serial killer, because it's like, a map with a bunch of pins and strings around it and stuff. No joke. I mean, it's still like that in some of these places. And then the second unlock was cloud compute. So, when cloud compute became available, suddenly you have this convergence of technologies that allow you to do so much more. And there'll be another unlock coming in the next, maybe call it 10 to 30 years, which is quantum computing. Because quantum computing is so powerful for optimization, and will unlock another generational leap of what we can do in simulating these things very quickly, very rapidly, very accurately. And then there's a kind of, shall we call it, cloud compute, and then a sub bullet under that, which is traffic data. So the other real key element is that, today we have access to the real traffic and historical traffic conditions for roads all around the world, because we have all of that GPS data flowing back from the in-cab systems.
Yeah.
So, there's a number of companies around the world that have those mapping systems in all the vehicles that we drive. And then they sell that data back to companies like us to then use it for things like optimization. So it's the convergence of all those things that really has given us this ability to do something that's relatively new. And then if you add an AI on top of it, that's a sweetener. It's opening up all sorts of other opportunities. But it was those other core technologies that really made the accuracy leap of what we need to do these types of simulations.
Oh, interesting. Yeah. And then from a sort of customer uptake point of view, almost, I've found one of the businesses I'm involved with now is a very new technology that people are not really thinking about. So it's a very different way of doing something compared to how people are used to doing it. So it's not even in the consciousness that, oh, I need one of those. It's very, in a lot of cases, there's an educational piece with the market. Do you find that your customers are now, are they actively seeking out the kind of things that you guys do, or are you having to kind of get in front of people and show them what the benefits could look like?
Mhm. Another great question. Okay, so the reality is that in our world, a lot of people are very aware of sequence optimization.
Okay.
They know that if you got 100 deliveries to do today, and you just give it to a human and say, just figure out the right order to do these 100 deliveries, it's going to be very suboptimal. No matter how good you are and how many decades of experience you have, it's just too complicated for a person to do. There's billions and billions of permutations that you need to sort through. So your instincts and your experience will do well. It'll do better than nothing, but it still won't be anywhere near what a very basic sequencing optimization can do. And for anybody who wants to look it up, it's the traveling salesperson problem. It's a very classic 70-year-old problem that's been studied for ages. So they're kind of they're aware that that's a thing they need to do to be more efficient, but still not all of them do it because the change management can be a bit painful. But for the most part, that's something that everybody's trying to do. But then what we do is the next level up. We say, okay, cool. I've got one driver that needs to deliver 100 things, and that's hard enough to do, and I can get some technology to help me. What if I have 100 drivers and I've got 10,000 things that I need to deliver, and I need to do it across multiple days? What's an efficient solution for that? And no human is going to be able to sit there and do it. So the heuristic hack that we've done for decades, especially at the big scale, postal organizations, big parcel companies like FedEx or whatever, that they just break everything into a postcode or a zip code,
Yeah.
and then have territories predefined. It helps. It's definitely more friendly and organized, but it's still not really efficient because you have massive volume fluctuations in those areas.
Yeah.
And that holds true whether you're a parcel delivery company or whether you're delivering food to cafes or you're delivering meal kits to people's homes, which, all these things, the old school way is to just break them into smaller and smaller problems that you can solve heuristically. We allow them to then look at that entire problem set and say, let's solve it all and get a really efficient outcome that can be different every day. Or what's more often the case is we kind of have a journey that we take them on, right? We take them on that journey from, you're doing things this way today. You've got your postcodes and your territories and all that stuff. And we know that you can't just change that overnight. You're a big enterprise. There's lots of change management we're going to go through, but we'll show you the art of the possible. We'll do those simulations and show you how much more efficient you can be. And then you'll go on the first step of the journey. And that's a big part of the education piece is that I think oftentimes it's seen as an all or nothing thing. Either you're using technology or you're not. And I think in our sector and any sector that has some of these operational constraints, you just need to be able to plan out a really clear path and a journey that's going to take anywhere from 1 to 10 years to actually execute on.
Yeah. Yeah. Slow but steady in terms of changing those sort of operations and businesses. So then there's obviously, there's an awful lot to what you're doing. You can tell the kind of depth of that from just listening to you speak. And you are obviously working closely with the customers and like you say, taking them on a journey and sort of educating them. What do you see as being the next kind of big step for you as a company? I mean, you mentioned quantum computing, but I'm guessing that's probably, I mean, I don't know, it might be, but is it in your sort of near term steps? What's the next big step for you guys? Is it quantum computing or is it something else?
Well, I think, we are really dedicated to electrification.
Okay.
And so we want to continue to build out those pathways to help people electrify their fleets in the most logical, lowest risk ways, right? Because we really do think that that's important. So we're actively building more technology in that space to help that. And that's, it's difficult because every region around the world has different pain points, constraints that they need to deal with, and different regulations. But one of the key things, especially in Europe and Canada and Australia, and to some extent, the US, is the regulations around emissions reporting and measurement.
Yeah.
That's becoming mandatory in a lot of places. So because we're already creating estimates around emissions for these vehicles, these fleets, that's something that we've marched into pretty headfirst to say, okay, cool, we can help you understand your emissions profile,
Okay.
and then also simulate how you can reduce it and put together a plan. Because that's something that's just becoming more attractive to a lot of brands too. You see what a lot of the brands like IKEA and PepsiCo are doing, and actually leveraging sustainability as a positive outcome. We want to help those brands because it advances our mission of electrification, and hopefully then those leaders help to catalyze so many more other businesses and influence policy and all that stuff. That's not really our place. We're optimization nerds. We just want to build the tools that help them achieve the results. But we do have that bigger vision, firmly around what we're doing to say, well, we want to build the tools that will help them to achieve those bigger macro goals that we would don't really have the resources or the interests to sit at the table with government, but we want to make sure that those companies that do have that influence have a great set of tools to do it.
That's interesting because actually, you think about the logistics industry as a whole, that there is there's a lot of concern around electric vehicles, a bit of they're a bit of an unknown. How are they going to perform? People look at the headline sort of range figure, and I often have had this discussion with people involved in that space of, my diesel van or diesel truck can do 500 or 600 miles, and this EV only does 120. It's useless. But trying to work out, and I'm particularly talking about vans and trucks there, because people can hear the people typing at me already saying that cars can do 300 or 400 miles, but typically vans don't have quite as much range as most of the cars available, and trucks, there's a thing there. But understanding, like we were talking about before, like testing these things out in practice can be pretty difficult. And actually there's a risk that if you took an EV into your fleet and you didn't use it right, you might end up with a wrong impression of what it could do for your business. So there's a sort of risk for that industry that without really the ability to simulate and model and look at different scenarios, they could be letting it pass them by. And it was interesting. I was at a conference last year, and they were talking about, it's actually deployment of the Tesla truck, and that it's incredible, semi truck, obviously not the cyber truck. So the fleets that were running the semi had found that it was actually best suited to certain types of long haul operation. And it was when they were presenting the results in the room, there was almost like a gasp, sort of, what? And then there was a lot of debate because in people's mindsets, electric trucks were only for short haul triage, local operations. But they'd kind of turned that on its head from the trials that they'd done. But it was a pretty slow process. The process of actually trialing trucks and gathering data, and they'd taken a long time to get to this conclusion about where they might get the best cost benefits. And you just sort of think, well, actually, if you had a simulation model, you could plug these things in, and rather than doing a 18-month extensive test, you could do some simulation and maybe a much shorter trial run, and get the vehicles in the fleets. Because actually, what they were saying was, there's some massive cost savings here, and if we believe if you don't do this in a couple of years' time, you'll be out of business because the costs are just so different if you're using these things in the right way. But if it's taking you a couple of years to do a small sample, and we're going to carefully test over on these routes here where we're confident they're not going to be a problem and they're not going to run out of charge and the rest of it, there's a chance you're going to get left behind, isn't there?
Absolutely. Yeah, there's a really interesting report by a consultancy here in Australia called Movement that basically did, I think, a very credible and good analysis showing the return on investment and the cost parity break point for different types of vehicles in the Australian market. And I know that other countries have had similar types of reports, but the thing is, like you say, there's been these horror stories of vehicles that get stranded during tests. They run out of charge, and then you need a rescue charge to go and get them or whatnot, and all these. And then that just sours the whole excitement and enthusiasm in the business when this happens. It's just relying when an organization has those failures, and it's hard for them to recover from it, to be honest,
Mm.
because it's already been such an uphill struggle just to convince the CFO that they should even take the risk on it. Then if there's a failure, a high profile one, it's just so hard for them to ever get that momentum back. So, one of the things that we have been really excited about just in the last few months is there's some projects that are using our routing engine. And so far, for long line haul, which of course does have a massive sensitivity to things like wind resistance and rolling resistance and aircon usage, is it refrigerated reefer, trucks. And so far, what we found is that our simulations are within 7% of the battery capacity, discharge profile of what happens in reality in the field.
Yeah.
And so if you can, simply use simulation, just like we're talking about, just like CFD and medical simulations and all these other wonderful things that we have, if we can use them for EVs, suddenly the innovation life cycle will collapse on itself. It'll start to fold in because your front innovation testing and your back end innovation testing will start to collapse and really condense the risk into the business process and less around the technology. And that's what I think we really need to make it successful, is to reduce the real and perceived risk of the vehicles not meeting the specs that the manufacturers, understand.
Yeah.
That's going to actually catalyze a lot of people to increase their faith and just be more successful with them.
Yeah. Yeah. Interesting. And then the mix with, I remember actually one of the comments you made earlier, it reminded me of a guy that used to work very closely with, and he was a senior engineer at actually a construction equipment manufacturer, off-highway machinery manufacturer. And he was very sort of actually obsessive about the, really in his space, in his domain, electrification was one thing for carbon, CO2 reduction, but really the machinery was so badly utilized typically in day-to-day operations in almost any place that optimizing the way that the diesel fueled machines were used was the first place to start. And there was a much bigger, quicker win there than going to fully electric machines and things which had lots more challenges. So do you see your technology helping with that kind of issue? And not specifically off highway machinery, but the optimizing the diesel is a potentially a really quick win.
That I'm glad you brought that up, Brian, because it's usually something I bring up. But we did an analysis, and optimizing existing diesel vehicles is the lowest cost carbon abatement methodology for fleets by far. It is much cheaper than electrifying your fleet to simply optimize it and do more work with less fuel burn. And it's a win-win because then you reduce cost off the top immediately, both your vehicle cost, your labor cost, your fuel spend, and all those things too. I think it came out to about $35 a kilogram of CO2 equivalent, per dollar spent.
Oh, wow.
Which is quite amazing, when you compare it to electrification, hydrogen, carbon capture, all of these other wonderful technologies that I think we obviously still need to invest in. But this massive low-hanging fruit of simply taking a fleet and optimizing it. And, a really concrete example is when one of our customers, we did you asked earlier about the business model. It is a SaaS subscription platform,
Okay,
right? But we've done, little bits of consultancy here and there, especially in our earlier days when we were still getting up and running. And one of these fleets was able to reduce their average distance by 36%. So the amount of total kilometers and miles that they were traveling is 36%, which is around, I don't know the exact CO2 reduction, but it would be in a similar kind of linear space to that, because that's generally like your metric for fleets is the kilometer. But the other thing that was super exciting for them is they were able to reduce their vehicle fleet size by 15%.
Yeah.
And these were very expensive, large 2-axle rigid trucks that cost hundreds of thousands of dollars. So, this this perception of where there's an opportunity immediately for these fleets is you can reduce the emissions and reduce the cost at the same time. And not only is it a cheap way to reduce emissions, you can actually make money doing
Yeah.
it.
That's really good. Sort of, yeah, really, really good data point to have. I have encountered personally, and I wonder, actually, probably your software just completely gets rid of this sort of issue. But I've seen it happen in some fleets where they didn't have particularly good data, and they were implementing it. They were implementing something. So, for example, your payload optimization, you know, you can run with less trucks, but they're going to be full more of the time. But then if the fleet is monitoring MPG as a parameter, if the trucks are running more heavily loaded all the time, they'll see their MPG get worse because they're carrying more weight. So I've been involved in a trial where the productivity went up massively, but the fuel consumption went up, and actually the fleet didn't have any data points for the productivity. They just were looking at the fuel consumption and going, "Oh, we don't like this. We're burning more fuel. You know, your technology is not working. What's happening?" And it took a lot of unpicking actually to work out what was really going on. Do you see that kind of thing happening much? And does it?
All the time. All the time, and I know what you mean, but right, because they've got these dashboards for fleet monitoring and visibility, and so that would be this big red flag on the dashboard. It's like, why is your MPG gone so bonkers? A really interesting one that we encounter all the time is that traffic data that I mentioned that we use. Right,
Yeah.
if you use an OpenStreetMaps model with no traffic awareness, right, it's going to assume when you do all of the routes, the delivery routes and stuff, that everybody's traveling at the speed limit on that road. And so when you do those routes and you do the productivity analysis on those, the metrics look really good because you're like, wow, I can do a lot of deliveries and I can travel all these kilometers and stuff. This looks really good on paper. I can get a lot of work done. Why don't the
trucks do this in real life?
And then you go and you do it in real life and you get massively disappointed. But it's tricky because for us, we'll go up against competitors that are using that data. They're using just traffic unaware data.
Yeah.
And we have to educate the customers to be like, yes, that does look better on paper, but when you go out and try it in the real world, hopefully not after you've invested a lot of money with them, you're going to be really disappointed. And we've got data to prove that. But it's such a counterintuitive thing, you know, because it does require peeling back a couple layers of the onion to really educate and understand. So really great analogy that you brought up there.
Yeah, cool. So then, just where are the time bringing us to a bit of a close? What are you most excited about? You know, looking forward to the next year or two for you and the business.
Well, we are looking at quantum. It's not going to happen anytime soon. We're doing some early experiments, and that's a lot of fun. Really exciting. The other thing that I'm really excited about is this convergence of robotics and agentic AI. So being able to imagine a world where autonomous vehicles can run large payloads of parcels and things like that. And then you have sidewalk, bipedal, or wheeled robots that can actually do a lot of the last meter type activity. This is another thing that people maybe misunderstand is that, yes, we're automating people out of jobs. That is the nature of what we do. But if you look at the statistics, we're doing it mindfully because there's, you know, just in the US alone, 450,000 supply chain jobs that are going unfilled right now and have been for 6 months. There's a massive labor shortage in supply chain, and that includes delivery drivers, warehouse workers, dispatchers, and things like that. Now, what we don't want to do is push people out of their livelihood at too early of an age. What we want to do and what we're really mindful about, and I think it's important for people to know that there's companies like us that are thinking this way, is we want to provide a transition for people that when they do cycle out of the workforce voluntarily or ideally voluntarily, we can help to automate what they were doing and all of that. But the message is that I'm really excited to see these opportunities to allow supply chain, which is the backbone of the global economy, to continue to evolve and to automate while mindfully helping people transition to other types of work. That's really important to us, and that's something that we're investing a lot of our time in doing.
I guess the strength of a simulation or the ability to simulate in that kind of scenario, and actually I've seen projects of both types in the recent past. So where companies try to automate absolutely everything from end to end is really difficult. So getting up and running, and quite often they'll sort of do some experimentation, go, yeah, this is going to be very, very difficult, very, very expensive. So they don't do anything. But then I've seen a number of companies a different approach where they go, you know what, automating absolutely everything is going to be really hard. So we'll have a more of a blended model, and we might be running there's a great example in this area where they're running autonomous trucks to move trailers around, but the system had like remote operated drivers that could step in, and there in that system, you reduced the number of drivers you needed, but you didn't get rid of them altogether, and it was much quicker to be able to implement than something that had no teleops intervention capability, because there were all the edge cases that in a fully autonomous system you just spend such a long time and such a lot of money trying to work around. Whereas in this case, you blend the system and use a mix of people and autonomous. It's easier to implement, but you've got to know how to do that. And unless you're running a massive trial, it's really difficult. It's because then it goes beyond the how do I route my vans. There's a much more complex situation to analyze and simulate. So yeah, I can imagine your software.
There's a massive amount of edge cases, right? Like a line haul vehicle doesn't come in with your deliveries. And so what do you do? And the automation would just, be like, oh, I don't know.
Yeah.
You need a human to call in and deal with that. Or a driver doesn't turn up to work because they're sick. You can't automate those things yet.
And they had, there was some like really interesting things. So even with the line haul truck, basically the normal day-to-day operation of a line haul truck, driving, going forwards, moving through the city, on the highway, what have you, all of that was pretty easy to automate. The one thing that was really hard to automate in every situation was reversing it up to the loading dock. So getting the conditions when you arrive at the loading dock was so critical to the ability of the autonomous system to be able to back it up successfully to the dock. If the space was too tight or there were obstructions in the way or things that a human operator would kind of go, oh yeah, shout at the guardman to move that thing or whatever. But the autonomous systems in so many instances couldn't perform the operation. So it was just much more successful to introduce at that point a human operator to take care of that part of the cycle. And there's lots of other examples, but it kind of, you could do 99%, but that 1% that you couldn't do was preventing you from making the big step that you needed. And I think a lot of people in operational, they do think about the 1% all the time rather than what can I do with the 99%.
Well, exactly like we were discussing earlier, right? We take them on the journey and try to understand those edge cases and defer them because, like you said, perfection is the enemy of good enough. And sometimes you just need to get started and start walking down the path, and eventually the other things will get clearer.
Yeah. Oh, fantastic. I think that's a really beautiful statement to end this episode on. So people who are interested in learning more, there'll be links in the show notes as usual. So link you up to Richard's LinkedIn profile and the corporate website and all that stuff. So if you want to get in touch with him, there'll be notes below. So thank you for taking the time out, Richard. It's been really nice to talk to you and get to know you in the business a little bit better.
Likewise, Ryan, really great to get to know you. I appreciate the time.